Bismillahirrahmanirrahim. So we are back with our another lecture, that is this charge transfer in the chemical sciences. तो चार्ज ट्रांसफर एक इम्पॉर्टेंट टॉपिक है. यूजुअली जब चार्ज ट्रांसफर की बात आती है तो एकदम से माइंड में आ जाता है कि कलर ऑफ द कॉम्प्लेक्सेस. We know that in the inorganic chemistry usually जो कलर आता है that is due to the DD transitions. Usually DD transition means that in the compounds or the complexes, the electron gets transferred from one d orbital to the higher one. So electron gets transferred from one d orbital to the next, like just हम कहते हैं T2G EG वाला concept, and then it absorbs the energy in turn, it gives color. But then it's not the case with all the compounds. It's not the case with all the complexes. There's one more concept that's called as a charge transfer. और चार्ज ट्रांसफर से होता है कि यू गॉट ब्यूटीफुल कंपाउंड्स, जबरदस्त कलर आता है इसमें. सो टुडे विल टॉक अबाउट द बेसिक्स अबाउट द चार्ज ट्रांसफर. अगेन एज वी नो कि हमारा जो एग्जाम है दैट इज द ऑब्जेक्टिव टाइप, सो आई विल बी मॉडिफाइंग दिस टॉपिक as per our need, and we should actually get enough information so that we can actually solve any type of objective which comes in the exam or any competitive exam. तो स्टार्ट कर लेते हैं. चार्ज ट्रांसफर का जहां तक ताल्लुक है, to understand this, we'll take example of एक टेस्ट कर लेते हैं, that's called iodine test. आपने सुना होगा iodine starch test. iodine टेस्ट एक होता है. What actually ये टेस्ट होता क्या है? If you want to test your sample whether that sample is a starch or glucose, या कहेंगे क्या आपके सैंपल में स्टार्च प्रेजेंट है कि नहीं. सो व्हाट वी डू इज दैट वी ऐड फ्यू ड्रॉप्स ऑफ आयोडीन. आपकी लैब में जो आयोडीन होता है इसमें आप फ्यू ड्रॉप्स ऐड कर लीजिए आयोडीन की. सो व्हाट यू विल एंड अप आफ्टर एडिशन ऑफ फ्यू ड्रॉप्स ऑफ आयोडीन टू द सैंपल, लेट अस से दैट सैंपल कंटेन्स द स्टार्च carbohydrate. So you will get an interesting color, that is the intense blue color. So you'll see your solution, your beaker, your whatever the setup you have taken, you will see an intense blue color. The appearance of this color is, आप यहाँ देखिए, आप यूज कर रहे हो आयोडीन को. Let us say it is in the molecular form I2. And you are using a starch, carbohydrate, and imagine that you have glucose units there, combined in different fashion, whatever. तो यहाँ तो कोई ना तो कोई inorganic compound है यहाँ पे, ना किस तरह का metal involved है. तो basically, it's proposed that the color, the intense appearance of this intense blue color, beautiful color, it actually arises due to some sort of complex formation between the iodine and the starch. So उसको मैं अगर यहाँ पे दिखा लूँ, let's say this is your starch molecule. So मैंने कहा कि starch जब माइंड में आता तो keep in mind that you have those sugars, right? So then iodine basically forms a complex with the starch, and that complex formed is actually, it's not a coordination complex. Sorry, it is not a when we say complex, that means we have some sort of bonding between these two. So it's a weak bonding between the two, weak bond between these two, iodine and starch. So it's weaker than the covalent bond. So it's weaker than your covalent bond, जो कि बहुत strong होता है. तो what happens जब इनका एक weak complex बन जाता है, इनके बीच में एक weak force होता है. So the charge gets transferred from iodine, which is electron rich, the starch. So because of that transfer of charge from iodine to starch, that transfer of charge, it's accompanied with the absorption of energy, light, and then you will get accordingly the color that's intense blue. So this is the basics, जो हम टेस्ट करते रहते हैं कि आपके पास अगर स्टार सैंपल में तो आयोडीन इंडिविजुअली ऐड कर लीजिए, get the color. If that's intense blue or close blue, sometimes black blue, then you say it's actually the presence of starch. So, in nutshell, we should say that actually in the charge transfer, we have a complex formed, fine, and then that results in the transfer of charge from one fragment of molecule to the other fragment of the molecule. Now that transfer is because it requires the electromagnetic radiation, and once it absorbs the radiation, that we know that you absorb the radiation, then in turn you get the output, that's the color. Fine. This is the charge transfer. So this is a weak electrostatic sort of interaction. अब यहाँ पे मैंने कहा कि there is partial transfer of electron or partial transfer of charge from iodine towards the starch. We say that now in the charge transfer complex we have a part that donates the electrons called as a donor, D. So it's a donor. And then we have another part that is called, which accepts these electrons. It's called as acceptor. So we have a donor acceptor system when our charge transfer comes into the mind. So this donates the electrons, it's called as a donor. So this accepts, it's called as acceptor. So there's basically, we said that the fraction of the charge gets transferred from donor toward the acceptor. So it's a donor acceptor complex. Acceptor complex. And that actually results in the output, that is the intense blue color. Now, if you जैसे हमने पूरा स्पेक्ट्रोस्कोपी में हमने डिस्कस किया है सारी स्पेक्ट्रोस्कोपी पर्टिकुलर यूवी विजिबल, तो ये टॉपिक यूजुअली यूवी विजिबल स्पेक्ट्रोस्कोपी में आप पाओगे. तो अगर हम इसको एनालाइज करेंगे, लेट से हमारे क्यूएट में हमने ये सैंपल ले लिया डोनर एक्सेप्टर का. सो वी हैव अ सैंपल हियर इन आवर सेल. यूवी विजिबल के लिए इसको हम मॉनिटर कर लेते हैं. देन यू पुट दिस इन द मशीन. So you will get a graph. हमने डिस्कस किया है. Please go through our UV visible spectroscopy lectures. So you have some bands here. Let us say this is your absorbance scale, absorption, and this is your wavelength scale in nanometers. At this point, हमने discuss किया है. Say please go through the lecture. It's called as absorption maximum. It's called as lambda max. So it's the point where a particular complex which have the maximum absorbance. Fine. So the output through the instrument, you will get this band. So this band is called as a charge transfer band. So this is your charge transfer band. So the output of this complexation is that you get a color, and then you get actually that color due to the transition of the electrons or charge from one fragment to the other fragment. Then you get basically the charge transfer bands. Ab question hai, is it possible that always you need to mix the two things, then you will get a donor kind of acceptor system? No, it is not that. It can be like we have, let us say, let me rub this first. So the charge transfer can be of two types. So this charge transfer complex can be of two types. CT complex. Can be that we have the transfer of electron or the transfer of charge within the molecule. So it can be within a molecule. You have a larger molecule, so it occurs within the molecular fragments. Though fragments molecule may, let us say, we'll make a rough molecule here, a cartoon molecule. So one side we have here one part, at the other side we have a part here. So it's a molecule, a cartoon molecule. This is your donor fragment, and this is your acceptor fragment. And then there's transfer of charge from this fragment to this fragment. So now it is we have a donor acceptor system within the molecule. It's called as the intramolecular system. So intramolecular, इसको कहते हैं intramolecular charge transfer. और यूजुअली ये हम डिस्कस करेंगे इन द कोऑर्डिनेशन कॉम्प्लेक्सेस. आई थिंक टुडे हम आज कर नहीं पाएंगे इसको. सो विल डिस्कस दिस इन द कोऑर्डिनेशन कॉम्प्लेक्सेस. in our syllabus, even though it can occur in the organic molecules. It's a complex chemistry here, but that will not deal here. Our syllabus, हमारे syllabus की जो है हमारा जो main concern है, that is usually the ligand and the metal and so on. So that we'll discuss in the coordination complexes. So for the moments, इसको आप ligand और metal के नाम से जानते हैं. So let us keep here. Let's move to the next. Fine. So there can be within the molecule, it's called intramolecular charge transfer, and it can be between two different molecules. Two different molecules. So two different molecules make an association between them, like iodine and the starch. Iodine and starch. So two different entities, they make the complex and there's a charge transfer. That's it's called as intermolecular charge transfer. इसको हम कहेंगे intermolecular charge transfer. So it can be within the same molecule, between the two different fragments of the same molecule, or two different molecules can combine. So this is all about the basics of the charge transfer transition. Now what actually happens? Let's move further. तो ये तो हो गया some basic points, the classification. अब होता यूं है कि now let's say that from the inorganic chemistry perspective, हमारा जो main है, that's inorganic complexes. So we have a donor part and we have acceptor part within the molecule. So basically, let us say, so the donor part and acceptor part. So electrons move from donor to acceptor, fine. When we say electrons are getting transferred from donor to acceptor, that's we are actually dealing with here. We say that a point that how much is it easier to get the electrons to transfer from the donor, or is it easier to make the electrons to get released from the donor? And then how much feasible it is for acceptor to accept it. When we say transfer electrons from donor, we are actually talking about a concept like oxidation. कहेंगे यहाँ पे donor is getting oxidized, fine, and acceptor is taking the electrons, so it is getting reduced. So the reduction of acceptor. So the concept of oxidation reduction comes into account. ठीक, fine. Now, अगर ये if the removal of electron from any wire, any entity, we say it's called as the concept is ionization energy. So then we say what is the ionization energy? It's required here, and then when it accepts the electrons, we say electron affinity. So the concept of electron affinity is here comes. So depending upon on this ionization energy and electron affinity, so it depends on this ionization energy and the electron affinity. Accordingly, we have the charge transfer, that is feasible or not. Now, if it is feasible, if it is easy, that means if this is easy, that means you require less amount of energy for transfer of charge from donor to acceptor. That means it is absorbed in the higher wavelength side, higher wavelength. So you have the beautiful colors which you can see. Your wavelength is ज़्यादा है, so that will fall in the visible region. Now, if it is difficult, if you require large amount of energy, so the overall energy required is larger for this, oxidation reduction process. That means it is difficult. The process is difficult, and so it will absorb in the lower wavelength region. You may not have the intense colors. So you may have the weak colors, fine, sort of closer to this ultraviolet. So it depends on basically, it depends on the overall, it depends on the energy balance, that is the difference in the energy. You take this into consideration, इसको consider करके, it depends on the energy difference, delta E. But that energy difference is basically the energy difference between the donor the acceptor's electron affinity. So it is basically acceptor electron affinity minus the electron affinity and the donor ionization potential, that is the ionization energy. इस concept के अलावा there is some equilibrium process involved. Molecules, the fragments or molecules, they have to have some equilibrium involved. So usually this energy depends on the electron affinity and the ionization energy. That will actually determine the how feasible the process is. Now we'll move to one more concept, that is the, जैसे मैंने पहले भी कहा कि our main concern, that's organic, this inorganic chemistry. तो हमारा जो concept है, that is, we'll say that we have an inorganic complex. When we say inorganic complex, so we have a metal and we have a ligand. So now, so if this is the case, now we have to see where from the electrons are getting transferred, whether they are transferring from ligand to metal or they are going from metal to ligand. अब ये कैसे पता चलेगा? If this is electron rich, let us say the case number 1, agar if your ligand is electron rich, that means the highest occupied molecular orbital. तो इसका जो highest occupied molecular orbital है, so that is इस complex का, that is ligand in character. So case number 1, if our highest occupied molecular orbital is ligand in character, that means, so the electrons will transfer from this to the metal, from ligand to metal. That means when they move from the HOMO, that means they will go into the LUMO of the metal, lowest unoccupied molecular orbital, which will be more dominant by the metal. So the electrons gets transferred from ligand to metal. So if the HOMO is more ligand-like, fine. So we should say that the charge transfer bands of the transition metal complex, they result in the shift of charge transfer from the ligands to the metals if the molecular orbital, that is HOMO, it is predominantly ligand in character. And if it is predominantly metallic in character, then we have a reverse, that if we have more HOMO, if it's electron, in the case number 2 we have, if this metal is electron rich, if metal is electron rich, so then the process is that it moves from metal to ligand. That means now the HOMO belongs to metal and LUMO, lowest unoccupied molecular orbital, it belongs to ligand. So you have metal to ligand charge transfer. So this is the case of metal to ligand charge transfer. So at this case, when the HOMO belongs to ligand, so this is the case of ligand to metal charge transfer, LMCT. So it depends on which characteristic your fragments of the complex are having. So whether it is ligand to metal or metal to ligand. So we should say if the transfer occurs from the molecular orbitals with ligand in character to the metal one, the complex is LMCT. It is ligand to the metal charge transfer. And contrary to this, if the electronic shift or charge occurs from molecular orbital with metal-like character, that is the HOMO, and then the electrons are getting transferred from metal to the ligand, is called metal ligand charge transfer. So that means if it is metal to ligand charge transfer, that is metal is, if it is metal to ligand charge transfer, so metal is getting oxidized, this is getting reduced. It is ligand to metal charge transfer, ligand is getting oxidized, metal is getting reduced. So we have the process of oxidation and reduction. This is in general the basics of the charge transfer in the inorganic chemistry. So in the next class we'll try to get more inside these. तो मैंने कोशिश की है कि इसको बेसिक्स में एक्सप्लेन किया जाए कि अगर आपका लिगैंड इट इज होमो, अगर आपका लिगैंड लाइक कैरेक्टर अगर मॉलिक्यूलर होमो का है, सो देन इट विल एक्ट एज अ इलेक्ट्रॉन डोनर. अगर होमो इज मोर ऑफ अ मेटलिक कैरेक्टर देन द मेटल एक्ट एज अ डोनर, देन वी हैव MLCT, otherwise you have LMCT. This is all.